Moving on, the next thing I did is a print statement which notifies the user that the program will check the IP reachability to each IP address in IP list. Next, I initialized a new variable with the Boolean value of false, as we did earlier. This will be used as a flag to make some decisions. Below is where the call function from the subprocess module is used to ping each device. The call function takes a list as a parameter, as you can see here, where the first element in the list is the command itself, in our case just ping, as you would type it in the Linux shell, and the rest of the elements in the list are actually arguments that you would pass to that command. In our case, the command, as I said, is ping, and its arguments are -c for count, then the number of echo request packets, then -w for timeout, then the number of seconds before ping exits, regardless of how many packets have been sent or received, then -q for quiet output, and then -n for numeric output, meaning no DNS names, and finally the IP address extracted from the IP list variable. I will attach a link to this lecture where you can find more information about the ping command and all of its options. Now let's actually open a Linux shell and try this command. So ping -c 2 packets, -w 2 seconds, -q -n, and let's use the loopback address. Okay, so we see that we pinged the address successfully. We have 2 packets transmitted and 2 received, and 0% packet loss. Okay, so this command right here can be issued from within Python using the subprocess.call method, as I just showed you. And using a for loop, we will run it for each IP address in IP list. Now, when pinging a device, the ping will either be successful or not. When it is successful, the ping command exits with the code 0. Otherwise, if something goes wrong, ping will exit with the code 1 or 2. This information helps us determine if the routers respond to echo requests or not. That's why I used an if block to filter the ping results. If the ping is successful, meaning code 0, then the check flag will be set to true and the program will continue to the next IP address in the list and ping that address. If code 1 or 2 is returned, then we print a specific message, keep the check flag false, and break out of the innermost loop, which is the for loop right here. Now inside the same while loop, but outside the for loop, we will evaluate the check flag. If the flag was kept false by the if-elif-else block above, then a message is displayed to the user, and the IP is valid function is called. Now notice that I call the function from within the same function. This trick is called a recursive call, and it is allowed in Python. In our case, calling the function will send the user back to the beginning of the function. So, up here. The logic behind this behavior is that if the device does not respond to a ping request, the user should verify the IP address in the file or the router interface and then input the file name again. Otherwise, if the code returned by the ping is 0 and the check flag is turned to true, then another message is shown and the program breaks out of the while loop and executes the code below. The next thing I did is I defined 2 other functions called user_is_valid and cmd_is_valid that actually ask the user to enter the name of the file containing the SSH credentials and the file containing the commands respectively. Since both functions behave the same, let's analyze only one of them, user_is_valid. The first line inside the function declares a global variable called user_file. This variable is going to store the file name the user enters when prompted, and it is going to be available outside the function too. To check that a file already exists on your operating system, you can use the isFile function from the os.path module by simply specifying the name of the file as an argument. Of course, in our case, we will pass the user file variable to the isFile function. If the file exists, then true is returned. Otherwise, we would have false returned. This is why I used an if-else block. If the isFile function returns true, then the program will print out a message and break out of the while loop to execute the rest of the code. Otherwise, it will continue to ask the user for a valid file name. The same logic applies to the cmd_is_valid function right here. Finally, after defining the three functions we've talked about, we should call them to really make use of their functionality. I could have just called them as usual, but I thought you might want to interrupt the program for some reason using Ctrl+C, and that's why I wrapped them inside try_except blocks. This way, the keyboard interrupt exception is handled in an elegant way by printing a friendly message and exiting using the exit function within the sys module.